So I've got 4 people here. So Varsha, Tanmaya, Shraddha, and Ritu. I'll wait for 2 more minutes and then I'll start the class. So Varsha, Tanmaya, Shraddha, and Ritu. I'll wait for 2 more minutes and then I'll start. Okay, Tanay is also here. Is my voice clear, guys? Okay, so I'll finish off circles today. So first part of the circle we have already done it. I'm starting with one question. Please solve this question. The question is, there is a circle like this and there is an external point E. And then we have points A, B, C, D. This is the center of the circle O, and I draw perpendiculars from here, which is point L, and one perpendicular from here, which is point M. And you have to prove that one second. You have to prove that BE is equal to DE, and second one is AE is equal to CE. OL is perpendicular to AE and OM is perpendicular to CD. Just solve this question. After doing this, let me know who all have done it. Done? Guys, let me know in the chat box, please. Done? Yes, AB is equal to CD. They are equal chords. One hint to you guys is if you have to prove that BE is equal to DE, and I've given that AB is equal to CD, so half of AB would also be equal to half of CD. So it means that BL will be equal to MD. So if you prove that EL is equal to EM, somehow what will happen is that from there, here you can subtract BL, and here you can subtract MD, and you can prove that B is equal to DE. And once you prove that B is equal to DE, you add AL and CM, which are of equal length, and you can prove that A is equal to CD. So you just have to prove here that EL is equal to EM. If you can prove that, that will suffice. For that, you need to do a construction here. So this OE you will have to match, and then of course you know that you will take two triangles, triangle OLE and triangle OME. Okay, Tana has done, Shraddha has done. So okay, I'm doing it OLE and OME. I know that if chords are equal, perpendiculars drawn to the chord from the center of the circle would be of equal length. So OL is equal to OM. I already know it. OE is common, and angle L is equal to angle M. So this is by theorem. This is common. This has been given. Hence, I have RHS congruency here. If I have RHS congruency here, then I can prove that by CPCT, EL would be equal to EM. Now, if EL is equal to EM, so EL minus BL would be equal to EM minus MD, as we already know that BL is equal to MD. Now, EL minus BL is EB, and EM minus MD is ED. Now what happens is this has been proved. Now once I have proved that EL is equal to EM, what I will do here is in EL I'll add AL, and in EM I'll add CM. So AL is equal to CM. So this becomes AE and this becomes CE. So now let me go to, I'll give you one more question and then I'll move to another topic. Apart from circles, is there any topic left out? I don't think so. We have covered up most of the things. Statistics is left out. Okay, I'll take one class on Thursday, and I'll finish statistics that day. Very easy topic. Any other topic other than statistics? So this is a circle and this is my center O. And what I do here is I draw a line OQ. I draw a line OP. I draw a chord AC. I match this, join this QC. I draw another chord AB and I join this PB. I given is AB is equal to, and this point is N and this point is M, and this is 90-degree obviously. AB is equal to AC. Then OM is perpendicular to AB and ON is perpendicular to CA. O is center of the circle. Prove that PB is equal to QC. Okay, probability and statistics are the two topics. Fine. Done. Let me know when you are done. Okay, three people have done till now. I'll wait for one more minute. What I'm thinking of taking a class on Monday to cover up statistics online. Is there any problem with anyone? Okay. Varsha, because I am not free tomorrow, I have to go to TISB, so I'll be unable to come to Rajaji Nagar because I get free only by 2:30. So it will be very late for me till the time I reach Rajaji Nagar. Anyway, on Thursday I am coming to Rajaji Nagar next week. So I'll take an offline class on Thursday and an online. This week I'm planning two classes. One tomorrow, one day after tomorrow on Monday, and one on Thursday. Thursday's class would be offline in the school, and Monday I cannot come. I can come, but I'll be very late because I leave TISP by 2 o'clock. So that's why tomorrow, I mean Monday's class I'll keep online, and Tuesday, Wednesday, and Saturday would be as you have classes in the school. So Thursday I'll try to take a class. I mean, not try it. Thursday I'll surely take a class there. And Anirudh, I'll take a class on Thursday in the school. That's what I'm saying. On Monday, let me take an extra class. I'm not saying I'll not take class in school. I'm only taking an extra online class because it will not be possible for me to come on Monday. I'm taking two classes this week, one on Monday online. Okay, let me solve this question. Enough time. So, what this question is all about is, if I have to prove that PB is equal to QC, I know that I'll have to take triangle OPB and triangle MPB and triangle NQC. So what I need to do is that I already know that if this angle is 90 degree, this angle is 90 degree. So you look at here, I will first take angle only. Angle PMB is equal to angle QNC, that is equal to 90 degrees. Now what about sides? I will take these two sides, MB. So I am saying that AB is equal to AC. So half of AB will also be equal to half of AC. And you see here, half of AB would be MB. And here half of AC would be NC. So the same I am writing here, MB is equal to NC. Now what I need to do, I know that, try to understand one thing. If AB is equal to AC, equal chords are there, then perpendicular drawn to equal chords from center, OM would be equal to ON. Now I know that OP is equal to OQ, which is radius. So if I take OP minus OM, that should be equal to OQ minus ON. So I'm writing here OP minus OM, which is equal to PM, and that is equal to OQ minus OQ minus ON. OQ minus ON, and that is equal to NQ. So what I have proved is, I have proved that this side and this side is equal and this angle is equal. So I have side angle side congruency, and with side angle side congruency I can prove that this PB by CPCT. Okay, Anirudh, if you are not feeling well, you can go, no issues. PB is equal to QC. So now I'll do a bit of theorems from the other part of the circles. So it's something like this. So now the topic is results on angle subtended by arcs. So I am taking first theorem in it. And first theorem is the angle subtended by an arc of a circle at the center is double the angle subtended by it at any point on the remaining part of the circle. This is a very important theorem with respect to concepts of circle. So what I do is I take a circle like this. I have to prove this, so I'm taking a circle C with the center O and radius R. Now what I'm doing is I'm taking an arc AB. Now arc AB is congruent to, or arc AB is synonymous with chord AB. So I have to prove that, and I am making an angle here. So this is C. So I have to prove that angle made by this arc AB at center O. So angle AOB is 2 times angle made by this arc AB on any point on the circle. So 2 times ACB. So first I am assuming that AB is a minor arc. So what I do is now you look at here, I am drawing a line passing through from here. I'm drawing a line passing through CO, which crosses here at somewhere. This is this I'm saying D. So you look at here, if I take this particular triangle, so in triangle AOC, this angle becomes exterior angle. So exterior angle AOD is equal to angle OAC, two interior angles, this and this, OAC plus angle OCA. And on this side, in triangle BOC, the exterior angle BOD would be equal to these two interior angles. So BOD would be equal to angle OBC plus angle OCB. Now I know that, see, this is radius and this is radius. So what happens is this angle would be equal to this angle and this angle would be equal to this angle. So what I'm saying over here is angle OAC is equal to angle OCA because this triangle AOC is an isosceles triangle. And why it is an isosceles triangle? Because OA is equal to OC, which is equal to radius R. And this triangle is also an isosceles triangle. And why this is an isosceles triangle? Because OB is equal to OC and which is equal to radius R. So these two angles are same. So what I can write is AOD is equal to 2 times angle, and I have to prove this OCA. So I'm taking the upper angle OCA, and angle BOD is equal to 2 times angle OCB. Now I'll add these two angles. So angle AOD plus angle BOD is equal to 2 times angle OCA plus angle OCB. And OCA and OCB is nothing but this complete addition of these two angles is nothing but angle ACB, and AOD plus BOD is nothing but 2 times angle, sorry, not 2 times, angle AOB. So angle AOB is equal to 2 times angle ACB. So this is how this has to be proved. Now let me go to another theorem. Theorem 2 is the angle in a semicircle is a right angle. So I draw a circle and then I draw a diameter, and this is point O, this is point A, this is point B, and then I draw a angle here. I have to prove that angle ACB is equal to 90 degrees. So try to understand how I prove this. I know that by theorem 1, which I just discussed, angle made by chord on circle, on center of circle, is equal to 2 times angle made on any point on circle. So this particular arc AB is making 180-degree angle here. And if it is making 180-degree angle here, then the angle 2 times angle ACB would be equal to angle AOB. So angle ACB would be equal to half of angle AOB. And angle AOB is equal to 180 degree. So 1 by 2 into 180 degree is equal to 90 degree. So this is how we prove that uh, angle made in a semicircle is 90 degree. Now let's move to theorem 3, and theorem 3 tells me that the arc of a circle subtending a right angle at any point of a circle in alternate segment is a semicircle. This is center O, and I will draw this line AB. This is my point C. So I know I have to prove that arc AB is a semicircle. And I know this angle is 90 degree. Given is angle ACB is equal to 90 degrees. So what I'll do, I'll find out the angle opposite of this. AOB would be equal to 2 times angle ACB. So 2 into 90 degree, which is equal to 180 degree. After this, I just have to write that AO and OB falls on same line AB. That's when the angle would be 180 degree. Hence, AB is a diameter and chord AB would be sorry, arc AB would be a semicircle. So this is what you have to prove here. Now let's move to another theorem. This is theorem number 4. So this is the second last theorem that I need to prove. So I'm proving for minor theorems. You just go through it once from your book and prove it for. I'm proving for minor sectors. You prove it for major arc and semicircle. So look at here. Angles in the same circle, angles in the same segment of a circle are equal. So let's draw it, and let's draw an arc AB. And suppose these are the 2 points. Sorry, this is the center, and these are the 2 points C and D. So let me draw a line like this, and a line like this. So angle, to prove that, angle ACB is equal to angle ADB. This I have to prove. Now, how I'll prove? So I'll prove like this. Angle AOB is 2 times angle ACB. I also know that angle AOB is 2 times angle ADB. Why I'm writing like this? Because both these angles have same arc AB. So that is why I can write that 2 times angle ACB is equal to 2 times angle ADB. And this 2 and 2 gone, you get angle ACB is equal to angle ADB. So this is what it is. Now this particular line can be anywhere. So if I make this line a diameter, and I have 2 points, suppose this is point O, I have 2 points ACB, and I have a point D, this and this is equal to 180 degrees. So I can write that angle ACB is equal to 90 degrees, because we just discussed a theorem which tells us that angle in a semicircle is a right angle. So ACB is 90 degree, that is equal to angle ADB. So we can prove it for semicircle. For major arc also you can prove it. So suppose I do it like this. So I take 1 point here C and 1 point here D, and this is A and this is B. So what I do is that I make this line like this. This is A, and I make one line like this. And this is center O. So what I can write over here is again AOB is equal to 2ACB. Same thing you will write here. Just you have to make a different figure altogether. Same thing which you have written for minor arc. The same thing you will write here and write that these two cases are same. Now let me go to the last theorem of this topic. And the last theorem of this topic tells me, which is theorem 5, that if a line segment joining 2 points subtends equal angles at two other points, lying on the same side of the line segment, then 4 points are concyclic. It means that lie on the same circle. Concyclic means lie on the same circle. So what do I mean? What I mean by this statement is, given to me is AB is a line segment. Let me draw first and then I will explain. Suppose this AB is a line segment and C and D, suppose a point C is here, and the fourth point I am not assuming on the circle. I'll take a different point D dash here and try to prove that these 2 points D and D dash are on the same circle. So D and DS are coinciding with each other. So AB is a line segment and C and D are 2 points. AB a line segment, C and D are 2 points on same side of AB. Now I know that I have to prove that ABCD points lie on same circle. So for that, what I have done is or let me take this point here so that I can make this at same line. So this point D is there. So and let me make this. So what I do is if point D falls on circle, then angle ACB is equal to angle ADB. But by figure but by diagram, angle ACB is equal to angle A dash B. So these two things are only possible. So which is saying that ADB is equal to angle AD dash B, which is only possible when D is equal to D dash, or D and D dash are coinciding. And hence we can write that A, B, C, and D are on same circle. So now let me move to 2-3 questions and let me give you questions. So one question is this. This is my circle. This is chord AB. This is center O. So I have this angle I am assuming to be Z. Then I have something like this. And then I have something like this. So this angle I am assuming to be Y, and this angle I am assuming to be X. This is ACE, and this is point F. This is point D. So you have to prove that angle X plus angle Y is equal to angle Z. And this is angle 1, this is angle 2, this is angle 3, and this is angle 4. And this point is point O. O is center of circle. Once you are done, just let me know. Just let me know when you are finished. Okay, three people have done. Shraddha, Tanay, and Sanjana. I'm waiting for 1 more minute so that others can give me answer. Okay. Okay, so I'll start solving this question. Now look at this angle. This angle is exterior angle. If I take triangle ACF, so exterior angle Y is equal to angle 1 plus 3. And I know that angle, now let me take triangle AED. So in that, exterior angle 4 is equal to angle 1 plus angle X. Now let me add this, angle 1 plus angle X plus angle Y is equal to angle 1 plus angle 3 plus angle 4. Now angle 1 and angle 1 is gone. Angle X plus angle Y is equal to angle 3 plus angle 4, and angle 3 and angle 4 are equal. So I write it 2 times angle 3, and 2 times angle 3 would be equal to angle Z. So I write that angle X plus angle Y is equal to angle Z. Now let me give you another question. And the question is, prove that midpoint of the hypotenuse of a right angle is equidistant from its vertices. Just prove it and let me know once you are done. Have you done? Okay, one more minute, nothing more than that. Okay, Varsa, I'll solve it. Don't worry. Okay, two people have given me the answer. What are others doing? Okay, let me solve it. So what I do is that I draw a circle and I know that and in the other circle I take a dash inside and I draw a line from here and this is 90-degree. What I have to prove that OA is equal to OB is equal to OC. So for this proof, these 2 points, if I have to prove, I just have to write that BAC is equal to BA dash C. In both the cases, is equal to 90 degree. It can only happen that when A and A dash coincide on each other. So if I have written that, then what happens is, if you look at here, exterior angle, if I take angle, if I take triangle BA dash C, we can also write that this angle A dash is equal to angle B plus C, because B plus C, if A dash is 90, B plus C would be 90. And what happens is, any exterior angle cannot be equal to its interior opposite angles. So it means that A dash and A will have to coincide. When they coincide, then the circle passing through these 2 points BC will also pass through this point A. It means that BAC fall on same circle. And if BAC fall on same circle, then OB would be equal to OA would be equal to OC, because this would be a radius of the circle. So that is how this needs to be proved. What I have tried to do is, I have not taken all 3 points on the circle. I have taken any other point A dash instead of A. I have tried to prove that this A dash and A coincide with each other, and then I have told that as BAC is on the circumference of the circle, then OB would be equal to OC, and that would be equal to OA, because any point on the circumference of the circle would be equidistant from the center, because it will be radius of the circle. So that is how you have to solve this. Now let me go to another question. And another question is, prove that the angle in a segment smaller than a semicircle is greater than a right angle. Do it quickly. Let me know when you are done. Done. So Tanay has done it. Sanjana has done it. Okay. Varsha has done it. Good. Okay. So enough time for this. What I do is I draw a circle like this, and this is my center. Now segment should be smaller than a semicircle. So this is semicircle. I'm drawing a line here, and then I'm drawing an angle here. So suppose this is A, this is B, this is C. I have to prove that BAC is greater than 90 degree. So let me go here. So I know that angle subtended by an arc of a circle at the center is double the angle subtended by it at any point of the circle. So you look at here, if I take a point D over here, arc BDC arc BDC, subtend angle BOC at the center. And BAC, angle BAC at point A. Now I know that angle BOC is a reflex angle. Why? Because why I write this? Because angle BOC would be greater than 180 degree. Why it will be greater than 180 degree? Because if I draw a line like this, and if I take this angle EOD or EOF, this angle EOF is 180 degrees. So anything which is going beyond in the other segment would be greater than 180 degree. So 2 BAC, BOC is equal to 2 BAC, and as BOC is greater than 180 degree, 2 BAC would be greater than 180 degree. Hence, BAC would be greater than 90 degrees. So this is what you had to prove. Now let me give you another question of this topic. We have solved 3 questions. We will solve 2 more questions of this type, and then I'll move to cyclic quadrilaterals, and then I'll finish the class. So now what I do is, let me draw the figure for you. So this is AB, this is CD, this is point E, and I join CB. This is AO, this is OD. AB and CD are given. These are the given data. AB and CD are chords, and they intersect at point E. You have to prove that angle AOC plus angle BOD would be equal to 2 times angle AEC. Just prove it and let me know once you are done. Let me know once you are done. Let's Radha is done. Okay, Ritu is done. 1 more minute. Tarna is done. Most of you are done, so let me solve it. So you look at here, what I do in this question is, what is AOC? AOC means this angle. So let me draw this line first. This angle is AOC. If this angle is AOC, it means that I am talking about this particular arc. So arc AC is making angle AOC. So angle AOC would be 2 times the same arc AC is making angle ABC. So it will be 2 times arc ABC. And angle BOD would be equal to, you look at here, when I talk about BOD, so let me draw a line here, BOD, and I am talking about arc BD, and arc BD will make 2 times angle. The same arc BD is making this angle 2 times BCD. So I added AOC plus BOD is equal to 2 times angle ABC plus angle BCD. Now try to understand angle ABC, because E falls on line AB. I can write angle ABC as angle EBC. I'm not doing anything. Instead of complete AB, I want to take help of triangle EBC. So what I'm doing is, because why I want to take help of triangle EBC, because I have to find this angle. So if I find this angle CEB, angle ACE, look at here, angle AEC is equal to 180 degree minus angle CEB. So this angle plus this angle is 180 degree. Now I will find out these two angles. So EBC plus, you see here, this angle BCD can be written as angle BCE. Now in triangle EBC, triangle EBC plus triangle BCE plus triangle plus angle EBC plus angle BCE plus angle CEB is equal to 180 degrees. So these two angles would be equal to 180 degree minus angle CEB. So what I am writing here is, this is equal to 180 degree minus angle CEB. Now this angle CEB from here can be written as 180 degree minus angle ACE. So I am writing CEB as, one second. So this will be 2 times 180 degree minus 180 degree minus the CB can be written as 180 degree minus EB, sorry, 180 degree minus AEC. CB can be written as 180 degree minus AC. Once again, I have made mistake here. Once again, guys. So this can be written as AEC. So I have written here AEC. So now this 180 is gone. This can be written as 2 times angle AEC. So this is how this question has to be done. Now let me give you another question of this topic, and this will be last question from this topic. Then I'll move to cyclic quadrilaterals. So now this is a circle, and I have AD here, I have BC here. I join these 2 points, make this. I see that this is point E. I say that BD is perpendicular to AC. This has been given. This is center O. This point is center O. And this angle is X degrees. This angle is P degrees. This angle is R degrees. This angle is Q degrees. So you have to find out angle P, angle Q, and angle R in terms of angle X. And let me know once you are done. Done, guys? One or two more minutes, nothing more than that. Okay. Okay. Okay, so few of you have already done it, so let me do it. What is this angle X? Angle X is angle subtended by arc AD, sorry, arc AD. So this arc AD is equal to this angle AOD would be equal to 2 times angle ABD. This angle ABD, so which is equal to half x degrees. Now try to understand if this is perpendicular, angle AEB would be equal to 90 degrees. So I know that this angle P plus this 90 degree plus this angle, which is half x, is equal to 180 degrees. So angle P is equal to 180 minus 90, 90 divided by half x. So P is 90 minus half x. Now this angle Q would be angle ACD, also would be half of angle AOD. So it means that Q would be equal to x by 2. Now I have to find out angle R, and what I'll do is that I know that angle ABE plus angle you look at here, this particular line AC is diameter. Why it is a diameter? Because center O falls on it, and if it is a diameter, this angle would be 90 degrees. So I am writing here angle ABC is equal to 90 degree, and angle ABC is angle ABE plus angle CBE. and that is equal to 90. Now you know this angle ABE is 1 by 2x. So angle CBE, which is angle R here, is equal to 90 degrees. So angle R is 90 degree minus 1 by 2x degrees. So that is how this has to be done. Now let me prove three theorems on cyclic quadrilaterals. So theorem 1 is the sum of either pair of opposite angles of a cyclic quadrilateral is 180 degrees. Or you can write the same thing, that opposite angles of a cyclic quadrilateral, and I am writing short form, is supplementary to each other. So suppose I draw a circle over here, and this is A, B, C, D, the center O. I have to prove that angle A plus angle C is 180 degree, and which is also equal to angle B plus D. Before I discuss this, you all know that a cyclic quadrilateral is that quadrilateral which all the points, all the vertices of the quadrilateral would be falling on the same circle or circumference of the same circle. So if I again repeat what I'm saying now, what I'm saying is a cyclic quadrilateral is that quadrilateral of which all vertices fall on the circumference of same line. So what I do over here is I have joined line AC and BD, and I know that angle ACB would be equal to angle ADB. Why? Because they are in same segment. We just proved that in a circle, angles in the same segment are equal. Similarly, angle BAC would be equal to angle BDC. Similarly, angle, so if I add it, ACB plus BAC is equal to angle ADB plus angle BDC. Now angle ACB, this angle, and angle BAC, this angle, is equal to angle ADC. So angle ACB, let me write here, angle ACB plus angle BAC is equal to angle ADC. So what I do over here is, and why I am writing this angle ADC, because you look at here, I have angle ADB and angle BDC. So this is angle ADC, ADB and BDC. So I'll write here, this is equal to angle ADC. So angle ACB plus angle BAC is equal to angle ADC. Now what I do is that I add on the both side angle ABC so that I complete this triangle, and I add here angle ABC on this side also. So what I get here is this is equal to 180 degree because this is complete triangle ABC. So this would also be equal to 180 degree. So what is angle ADC? Angle ADC is angle D and angle ABC is angle B. Angle D plus B comes out to be 180 degree. Now I know that angle A plus B plus C plus D is 360 degrees. So B plus D, I have already told that it is equal to 180 degrees. So angle A plus C would be 360 minus 180, which will give you 180 degrees. So this is how you have to solve this. Now let me move to another theorem, which is if a pair of opposite angles of a quadrilateral, it is a converse of the first theorem, it's supplementary, then it is a cyclic quadrilateral. And for this, you know that I have to prove that 4 points are on same line, sorry, same circle. So one of them I'll not take on circle. What I'll do is that I'll draw 2 lines, AB, this is the line. So I'm taking this, this is point C. So I'm matching this. And this is point D I'm taking here. And I'll join this, and on the same point, on the same line, I'll take a point D dash, and I'll try to prove that D and D dash are coinciding on each other. Wherever you have to prove that 2 or 3 points or 4 points are on same circumference, one of the point you take outside or inside of the circumference, and on the same line on the circumference, show any other point and show that those 2 points are coinciding. So what I'll write over here is angle ABC plus angle ADC is equal to 180 degree. It has been given to me that opposite angles are supplementary, but at the very same time, ABC plus AD dash C is also equal to 180 degree because by diagram I have made like that. And this is only possible when angle ADC is equal to angle AD dash C, which tells me that this is not possible since exterior angle of a triangle can never be equal to its interior opposite angle. So this exterior angle, if I draw a line, this exterior angle can never be equal to of a triangle can never be equal to interior opposite angles. So this cannot be equal to this. So this 90-degree cannot be equal to, or this angle cannot be equal to this angle, because um, so this is only possible when D and D dash are coinciding. So I have proved that all ABCD are falling on the circumference, hence it is a cyclic quadrilateral. Now I have a theorem 3. If one side of a cyclic quadrilateral is produced, then the exterior angle is equal to the interior opposite angle. And this is nothing but, what I'm saying you is that I draw a cyclic quadrilateral like this. This is A, B, C, and D. And if I produce this line BE, I am saying that angle CBE, this exterior angle, would be equal to angle D. So I can write that angle B plus angle D is equal to 180-degree, and angle CBE is equal to 180-degree minus angle B. So angle D would be equal to 180-degree minus angle B from here. So this will be equal to angle CBE. That is what you have to write over here. So this is how it has to be proven. These are the three theorems which are required for cyclic quadrilateral. I have proved everything. Now we will solve 4-5 questions and then we will wrap up the session. So the first question which I'm giving you is, prove that every cyclic parallelogram is a rectangle. Solve it and let me know once you are done. Okay, 3 people have done. There is nothing in this question. Just draw a parallelogram here. And this is A, B, C, D. Parallelogram, I know opposite sides are equal. If I prove that all angles are 90 degree, I'll be able to prove that it's a rectangle. So opposite sides are equal. So I write that AD is equal to BC and AB is equal to CD. I have written this. Now angle A plus angle C is equal to 180 degree. But in a parallelogram, opposite angles are also equal. So angle A is equal to angle C, hence A is equal to C, that is equal to 90 degree. And same I can write here, B plus D is equal to 180, and B is equal to B is also equal to D. So this is also equal to angle B and D. So I proved that all angles are 90 degree and opposite sides are equal. Hence, ABCD is a rectangle. Now let me go to another question. This angle is 84 degrees and this angle is 80 degrees. You have to find out angle QBC and angle BCP. Uh, I'll take class till 5:45. So 20 more minutes. Okay, it's Shraddha has done it. Tana has done it. 2-3 people have done it. Um, okay, most of you have done it. Still, I'll do it. So this line PQ has been drawn. Now try to understand in if I have to find out QBC, this triangle. So first I'm trying, and then I have to find BCP. So this angle. So what I'm trying to find first, I'll finish it on this side. So this angle would be 100 degrees, and this angle would be 96 degrees, because in a cyclic quadrilateral opposite angles are supplementary. So this angle would be 80 degree, and this angle would be 84 degrees. Again, this angle would be 100 degrees, and this angle would be 96 degrees. So all the angles I have written over here. There was nothing in this question. Now I'm drawing another circle, and this is A, this is B, this is Q, this is C, this is D, this is P, and I will match this P like this. So this angle is 60 degree, and sorry, and this angle is 80 degree. You have to find angle DPC and angle BQC. Let me know when you are done. Okay, Ritu has done it. Anyone? Okay, think Sanjana is saying I need to solve. Dhruti, I think, has done it. Fine. So you look at here. Angle PDC, this angle. How will I find angle DPC? Angle DPC is nothing but angle A plus angle B plus angle P is equal to 180 degree. And angle P would be equal to 180 degree minus 80 minus 60. There is nothing else in this. So this will be equal to 40 degrees because in triangle ABP, this is 60, this is 80, so this is 40. There is nothing in it. Now I have to find out angle BQC. This one I have to find out. So what is this angle? This angle is 80, so this angle would be 100. So this angle, so in triangle QAD, angle A plus angle D plus angle Q is equal to 180 degrees. So, and this is 60, this is 100 is equal to 180 degrees. So angle Q is equal to 180 degrees minus 160 degrees, which is equal to 20 degrees. So write down, question is, in an isosceles triangle ABC, AB is equal to AC. A circle passing through point B and C intersects AB and AC at points D and E. Prove that DE is parallel to BC. Are you guys done? Okay, I got two people saying that they are done with it. So what I do is I draw a circle, and here is my chord BC, and this is point A, and I draw a line which is ED. So I know that AB is equal to AC, and then angle ABC is equal to angle ACB. Now side BD of the cyclic quadrilateral is produced to meet at A. So of cyclic quad is produced to meet at A. This is the case. So angle ADE is equal to angle ACB. Why? Because try to understand, if this angle is X, this angle is 180 minus X, and so this angle will be X. So in a cyclic quadrilateral, we just proved that theorem that the exterior angle of the opposite angle would be equal to this interior angle. So angle AD is AE is equal to angle ACB, and so this angle and this angle are equal. Now try to understand, this angle is also equal to this angle. So I can write it as this is equal to ABC. So ADE is equal to ABC. So this is X and this is X. So these are corresponding angles. And if these are corresponding angles, it can only happen when BC is perpendicular to DE. So this is how you have to solve it. One more question and then I'll finish off the session. The question is, prove that the altitudes of a triangle are concurrent. Will you done? Okay, so few people are saying me that they have done it. Few people are saying I'll have to solve it. So see, what I'm doing is, let's take a triangle ABC, and BE is perpendicular to AC. CF is perpendicular to AB, and they intersect at point O. And this is BD. I have to prove that what I'm doing, I'm drawing two perpendiculars. So given is CF perpendicular to AB and BE perpendicular to AC. What I have to prove is AD is perpendicular to BC. Why? Because I have shown that both all the points are passing from O. So BEC is equal to angle BFC, which is equal to 90 degrees. Now you try to understand, if I draw a triangle like this will not be possible until and unless I prove that these points E and F, because they are making 90 degrees, this will not be possible until and unless I prove that this E and F are on center of the circle, because making this 90 degree will not be possible until and unless they are in look at this. If this is a line and this is making 90-degree angle here in a circle, this point has to be on the um, circumference of the circle. So that is why I'll have to make a different line where I'll prove that this is B, C, F, E, and I will draw this, and this would be somewhere here. I will draw something like this. This is E, not this is E. And I'll draw a line, and then I'll draw a line from here, and I'll write that, because what happens, this CF is perpendicular here and this is perpendicular here. This is not possible. So what I'm saying is angle BC, or sorry, quadrilateral BCEF is a cyclic quadrilateral. So if it is a cyclic quadrilateral, angle ECB plus angle BEF is equal to 180 degree, and similarly angle ACD plus angle BFE is equal to 180 degrees. So why this is possible? Because angle ECB is also equal to angle ACD. This is A. So to solve this, I write angle ACD, and BEF can be, BFE can be written as angle BFO, which is here, plus angle OFE, which is equal to 180 degree. So I know that angle ACD and BFO is 90 degree. So 90 degree plus angle OFE is equal to 180 degree. So angle ACD plus angle OFE is equal to 90 degrees. So what I'm proving, that EF, so from here I can write that, I'll have to make some space here. So from here I can write that angle OFE would be equal to angle OAE, because they are in same segment. So now I can write that angle ACD plus angle OAE is equal to 90 degree, and this OAE is equal to DAC, which is also equal to 90 degree, because angle OAE is equal to angle DAC. But in triangle ACD, I know that angle ACD plus angle DSC plus angle ADC is equal to 180 degree. So angle ACD plus this angle DAC is equal to 180 degree minus angle ADC. So I can write this as 180 degree minus angle ADC is equal to 90 degrees. So angle ADC is equal to 180 degrees minus 90 degrees, which is 90 degrees. So ADC, this angle is 90 degree, hence AD is perpendicular to BC. This is what we had to prove. Now I am wrapping up the session. If you have any doubt, you can ask me in next class. Next class I'll be taking online on Monday. So I will post the timings in the group, or let me post the time in the group. What is the time when you all are comfortable? Are you comfortable from 6 to 8 kind of timing? It's 6 to 8 p.m. fine for Sunday's class. Sorry, Monday's class. Okay, fine. So next class would be on Monday, and I shall be taking that class online. Fine. Chalo, thank you so much for joining the class.